Okay, so in this video, I will explain on the Laplace transform properties. Okay, so basically we have three properties. The first one is linearity property. So the second one is first shifting property, and the last properties is multiplication by Tn. Okay, so we will go through one by one. So for linearity property, let f1 and f2 be the function whose Laplace transform exists for s greater than a, and c be a constant. Okay, then for s greater than a, so you have, if you have two different function f1 and f2, so the Laplace of f1 plus minus f2 is equals to the Laplace of f1 plus minus the Laplace of f2. So meaning that here you need to separate f1 and f2. Okay, and if you have a constant here where c is constant, so to do the transformation, you can take out the c and then you do the Laplace transform as usual. All right. Okay, so for this example, let's say you have the Laplace of let's say your function is 1 plus 5e power 4t minus 6 sine 2t. So you need to find the Laplace of this function, right? So the Laplace of this function can be written as the Laplace of 1 plus the Laplace of 5e 40 minus the Laplace of 6 sine 2t, and each term will be solved separately. Okay, all right. So basically, to solve this Laplace transform, okay, you can actually refer to the table. Okay, so how to refer to the table? Okay, let's say the first function is 1. Okay, so for this, to solve this, I will keep on scroll up and down to refer to the table. Okay, so let's say your function is 1, so you need to find the Laplace of 1. Okay, so you go up, go up. Okay, so the Laplace of constant is a over s, so meaning that constant over s. So constant over s. So that's why for Laplace of 1, you have the constant itself 1 over s. Okay, and for et, for the exponent function, okay, for exponent function, EAT is equals to 1 over s minus a. So 1 over s minus a. Okay, so since 5 is constant, so we can take out constant. So in this case, we just do the transformation of exponent of 4t only, and then the exponent of exponential function, sorry, the Laplace of exponential function is given by 1 over s minus a just now, right? So your a is 4, so that's why we have 5 over s minus 4 here. Okay, and for the last function, which is 6 sine 2t, so since 6 is the constant, so we can take out, will be here. So you just need to do the transformation of sine 2t only. So let's see what is the transformation of sine 80. So sine 80 is equals to a over s squared plus a squared. Okay, so sine is a over s squared plus a squared. So in this case, your a is 2. Okay, 2. So for sine 2t, after you do the transformation, you'll get 2 over s squared plus 2 squared is 4. Okay, but here you have 12 for the numerators, because you have 6 as a constant here. 6 times 2 is 12, right? So that is how to uh, to solve the Laplace transform by using the table. Okay, all right, next we go to the first shifting property. So if the Laplace of ft is equals to fs, then the Laplace of e power at ft is equals to fs minus a. Okay, so how I'll show you by proving by using the definition. Okay, all right. So you know that the Laplace of ft is equals to fs, and this is equals to the improper integral of e minus st ft dt, right? Okay, so the Laplace of EAT ft is equals to integration of, this is the improper integral of e minus st times EAT times ft dt. Alright, so this is equals to e minus t s minus a, and then ft dt. Okay, so let's say r equals to s minus a. Okay, s minus a is from here, from the power here. Okay, so let's say r is equals to s minus a, so you will have e minus rt times ft dt. Okay, so when you compare with this definition, okay, so fs is equals to improper integral of e power s minus st ft dt, right? But here you have the improper integral of e to the power of minus rt ft dt. So this is equals to fr, right? Because e my power of st is for fs. So if you have e power minus rt, then this is for fr. So what is fr just now? Fr is s minus a. So this is actually f s minus a. Okay. So this one you have to remember. So this is the first shifting property. Okay, so let's try example 4. Find the Laplace of e power 2t. Okay, so in this case, in this question, it is mapped to the Laplace of EAT ft. Okay, where it is equals to f s minus a. Right. So in this case, your a is equals to 2. Right? A equals to 2. Your ft equals to t. So fs is equals to the Laplace of ft, right? Okay, so it is equals to, what is your ft? T. Okay, so for the Laplace transformation of t, if you go back to the table, okay, you go back to the table in page 5. Okay, so for a function of t to the power of n, the Laplace transform of the function is n factorial over s to the power of n plus 1. Okay, so for this function, for t function, this is t to the power of 1, right? So if t to the power of 1, then it is 1 factorial over s to the power of 1 plus 1, which is 2 s squared. Okay, so the Laplace transform of t is 1 over s squared. Alright, so this 1 over s squared is fs. Okay, but we need to find the Laplace transform of e to tt. Okay, so the Laplace transform of e a t f t is given by f s minus a, right? So now you have fs, which is 1 over s squared. So if you want f s minus a, means that here will be 1 over so this will be f s minus a sorry, this is 2t. 2t, um, um, okay, let me just write as usual. At, this is ft equals to fs minus a, alright, and then it is equals to 1 over s minus a is 2 square. Okay, can understand? Alright, so now let's try the next example, okay, which is the function is given by e power 4t cos t. Okay, so you have e at and a function here, so it is mapped to the Laplace transform of e at ft, and it is equals to f s minus a. Alright, so in this case a equals to 4 t ft. Ft function is cos t. Okay, so fs is equals to the Laplace transform of ft. Okay, so what is your ft? Ft is cos t, right? So the Laplace of cos t. So from the table, okay, from the Laplace table in page 5, you have cos. Please refer to the table as well, don't just depending on me. Okay, so cos at, for function of cos at, so the Laplace is s over s square plus a square. So if you have cos t, where a is 1, so you will have s over s square plus 1. So this is s over s square plus 1. Okay, so this is the function of fs only. So for the Laplace of e for t cos t, it is equals to fs minus a. A is 4, right? So it is equals to s minus 4. You replace s minus 4 into s over, this is s minus 4 square plus 1. Okay, now let's go to the third properties, which is multiplication by Tn property. Alright, so if the Laplace of ft is equals to fs, then the Laplace of t power n ft is equals to minus 1 to the power of n dnf over dsn, where n is equals to 1, 2, and so on. Okay, now you have for example 6, you need to find the Laplace of t sine 60. Okay, so this t sine 60 is mapped to the Laplace of t and ft, okay, which is equals to minus 1 to the power of n dnf over dsn. Alright, so in this case, your n is equals to 1, your ft equals to sine 60. Right, so your fs equals to t is equals to sine 60. Okay, so from the Laplace table, sine 60 is given by sine 80. Okay, sine 80 is equals to a over square plus a square. So if we have sine 60, it is 6 over square plus 36. Okay, so this equals to 6 over s square plus 36. Correct? So this is fs. So because we need to find the derivative of f function, right? So df over ds, since our n is 1, so we just need to differentiate one time only. So d over ds 6 s square plus 36 power minus 1. So this equals to 6 minus 1 s square plus 36 minus 2 s. Okay, so basically we'll get minus 12s. Alright, so this is the derivative of fs function. So t sine 60 equals to, the formula is minus 1 power n. So minus 1 power 1 . Okay, so you rearrange, you get you get 12s over s square plus 36 squared. Okay, so this is the Laplace transform. Okay, for example 7, alright, you need to find the Laplace of e to the power of minus t sine to t. Okay, in this question you have to be careful because you have three different functions here. Okay, three different function of t: exponent, polynomial, and sine. So for this Laplace transform, we need to transform one by one. Okay, one by one. So you need to see carefully. So firstly, the Laplace of e minus t sine to t is mapped to Laplace of e ft equals to f s minus a. Right? You have exponent function here, and here we have exponent function. So the Laplace of exponent ft is equals to fs minus a. Okay. So in this case, a is equals to minus 1, ft equals to t sine 2t. Okay, so fs equals to the Laplace of ft, which is equals to the Laplace of t sine 2t. Okay, so I'll put star here so that we will go back to this transformation later. Okay, so the second step is for you to find the Laplace transform of t sine 2t. So the Laplace transform of t sine 2t, okay, can be mapped to the Laplace transform of Tn ft equals to minus 1n dnf over ds power n. Alright, so in this case, your n is equals to 1. Okay, meaning that we only need to differentiate one time only. Alright, so ft equal to sine 2t. Okay, so your fs is equals to the Laplace transform of ft, right, where your ft is sine 2t. So based on the table, if sine 80 Okay, then the Laplace transform is a over s square plus a square. Okay, so in this case, it is equals to 2 over s square plus 4. Okay, so since we have n equals to 1 here, so we need to differentiate one time only. So do the first differentiation. So df, so this is your fs. So fs is this one. Okay, so df over ds is equals to d over ds 2 s square plus 1 plus 4 minus 1. Okay, so you differentiate, you get 2 minus 1 s square plus 4 minus 2. This one is 2s. So you will get minus 4s over s square plus 4 square. So this is your df, okay, over ds. So the Laplace transform of t sine 2t is equals to, okay, so the Laplace transform of t and ft is equals to minus 1n dnf over dsn here, this one. So for this one, it is equals to minus 1 to the power of n is 1, okay, and df over ds. So df over ds is minus 4s over s square plus 4 square. So it is equals to 4s over s square plus 4 square. Correct? So we go back to the star just now. Okay, now we have the Laplace of t sine 2t is equals to 4s over s square plus 4 square, right? Okay, so we have this answer now. Okay, so we have this answer. So we go back. So Fs from here, from the first step. Okay, so the Fs is equals to Laplace of t sine t equals to okay, I copy back this one. 4s over s square plus 4 square. Okay, this is the Fs for this one. So the Laplace of the whole function e minus t sine 2t equals to f s minus a. Okay, so we will follow this one. S minus a. So your a is minus 1. S minus a. So plus 1 over s plus 1 square plus 4 the whole thing square. Okay, so basically this is how to do when you have more than two functions, more than two different functions. Okay, you need to do one by one, and then okay, like you go forward and then you go backward, like that. Okay, so please try the past year test, and that's all for today's video. Right, thank you.